Right, so our last section for this week is 7.4. Okay, it's on trig identities. Okay. Remember that an identity, okay, in general, is an equation that is always true. Okay, it's an equation that's always true. Okay, and of course, when we plug numbers in, we're assuming that the numbers are actually in the domain. Okay, you can't plug a number that's not in the domain into an equation. So for all numbers that actually work in the functions you're using, it's true. Right, so here's an identity that's something you might see in Algebra 1. Okay, if I asked you to solve this equation, let's say, so on the left, I have 3 times 2x plus 1. And on the right, I have 5x plus x plus 1 plus 2. Okay, what would happen if you simplified what's on the left and on the right?
6x plus 3 plus 3 and 6x plus 3.
Right, you get 6x plus 3 equals 6x plus 3, which means if you subtracted 6x from both sides, you get 3 equals 3. That's a true statement. It means this is an identity. So no matter what number you pick for x, what's on the left will always match what's on the right. Okay, they're exactly the same thing, except one's just been factored, and the other one needs to have like terms combined. But they're the same thing. Okay, that's an algebraic identity. All right, so we should already be familiar with the reciprocal, the tangent and cotangent, are sometimes called the quotient identities, and the Pythagorean identities from an earlier section. Okay, if you don't remember them, okay, here they are again. Okay, so first is our reciprocal identities. Okay, so if you flip your cosecant, you get sine. If you flip your secant, you get cosine. If you flip cotangent, you get tangent. Okay, if you flip sine, that's cosecant. Flip cosine, that's secant. Flip tangent, that's cotangent. Okay, we've had to use these all along because it's the only way we can type in secant, cosecant, and cotangent into the calculator. Okay, the quotient identities, sometimes you can also call them the tangent, cotangent identities. Sine over cosine is tangent. Cosine over sine is cotangent. Okay, and the last 3, I think I gave you these, but we've never really done any work with them, are the Pythagorean identities. It says sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. And 1 plus cotangent squared equals cosecant squared. All right, so on the board, maybe I have, 6, 7, 8, 11 different identities. There's hundreds of identities. Okay, if you take like any trig book and usually flip to like the inside back cover, okay, not in your book, I guess. That's usually where they list them all. Identities besides these are not really something you memorize. There's something you look up, you use them when you need them, because they can get pretty complicated. Okay, but these 11 are ones you should know. Okay, they're the very fundamental, basic identities. Right? And again, since they're identities, it doesn't matter what angle you use. Okay? You can use any angle you want. Sine squared plus cosine squared is always going to be equal to 1. Okay, any questions on that? All right. So one reason why we might use identities in calculus is to make an expression easier to work with. Okay, make it simpler. So we're going to take, so you might have an expression that has a lot of trig in it, and sometimes we can cancel some things out and make it simpler. Okay, so that's going to be our goal. Okay, and there's different tricks we can use, okay, to simplify identities. And the first trick, this one's used a lot, change everything in your problem into sines and cosines. Okay, every single function in trig can be written with just sine and cosine. So if you think of tangent, you can write it as sine over cosine. Okay, think of cosecant, 1 over sine. Okay. Everything can be done with just sines and cosines. Right, so that's the first thing we'll try. Okay. Right, so we've got cotangent divided by cosecant. Okay, we're going to try changing everything here to sines and cosines. And chances are something will cancel out. All right, let's start with the top. Okay, how can we rewrite cotangent?
Cosine.
Yep, we can write it as cosine over sine. And how can I write cosecant?
1 over sine.
1 over sine. And now when you have a fraction divided by another fraction,
The signs cancel.
how do we do that?
The second one.
Yeah, you can take, yeah, you can, that's one way to do it. Just take the one in the bottom, flip it, and multiply by the one in the top. Okay, or you might have just noticed they each had the same denominator, so the signs cancel out. And what are we left with? Cosine. Right, so that's a pretty straightforward identity. Sometimes it's tricky to know where to stop. Like, should we do more work to simplify? I think this one's straightforward. You're down to a single trig function. I mean, you can't simplify it much more than that. Okay, any questions on that one? So tip one, see what this is saying? Okay, so if you took an angle and you took the cotangent of it and divided by the cosecant, a shortcut would be just take the cosine of the angle. Right? This is a lot easier to work with than this. Okay? First of all, you have this button on your calculator. Second of all, it's not a fraction. So it's much, much easier to work with. Okay, here's another one. Again, if I see things that aren't sines and cosines, that's, again, it's not always what you want to do, but a lot of times it's something to try first. All right, so what is cosecant? 1 over sine. And what about tangent? Sine over cosine. Okay, and what happens there?
Signs cancel.
Sines cancel. And at this point, I'm left with 1 over cosine.
Which is secant.
Yeah, and in this case, I would argue that you can simplify this a little more to something that's not a fraction. Secant. Okay, so with identities, really, one of the hardest things is you have to know the 11 basic identities. If you don't have them memorized, then you might forget, oh, I don't remember how to flip this or things like that. Okay, any questions on example 2? All right, so now we're going to look at something with different directions, okay? Simplify versus verify. Well, I think verify is a little easier. Okay, what they do in a verify problem, I'll show you one, is they give you something on the right, they give you the answer on the left. So we know this is what we're supposed to get somehow. So you just take what's on the right and work with it till you get what's on the left. Okay, so you know where to start, you know where to stop, fill in the middle. With simplify, you just keep going until you think you're done. Okay. Right. Sometimes when we're working with identities, I usually start with the more complex side and try to make it simpler. Right? So in this example, I would start with what's on the right and try to make it look like what's on the left. Okay? And we do that by changing to sines and cosines. Things cancel. Don't start what's on the left and try to make it look more complicated. Okay, that's going to be a harder way to do it. Okay, you can also simplify both sides at the same time. I generally don't do that. Okay, you could do a little work on the left, a little work on the right, and try to make them match. Okay, I usually stick with one side and just keep working with one side at a time. Okay, so a second trick that comes up quite a bit is to use common denominators. Okay, so if we have two fractions that are separate with different denominators, sometimes finding a common denominator just makes nice things happen. All right, in this problem, example 3, right away I wouldn't say we're going to be doing anything with common denominators. We might as we go on, maybe after we change the sines and cosines. But this is not going to be a first step in this problem. What do you think the first step would be in example 3? Well, I guess you have two choices, but not only cotangent, but tangent. Yeah, we could change everything to sines and cosines. What else could we do?
Distribute.
Yeah, we could distribute. You're going to have to do both of those things. Okay, the order you do them in, it doesn't really matter. Okay, I tend to do the distribute first. So we've got sine times cotangent plus sine times tangent. Okay, any questions on the first step? All right, now I'm going to change everything to sines and cosines, and that's going to give me fractions. At that point, maybe I'll start looking at, if I have different denominators, putting them together. Okay, what's, Kanan, what's cotangent?
Cotangent is cosine over sine.
Yep, cosine over sine. Cotangent is also 1 over tangent, but that's not going to help because we'd never see what cancels if we did that. Okay, plus, keep that as sine. And what about tangent?
Sine
Sine over
over cosine.
cosine. All right, what can I do next?
Cancel out the sign.
Yep, I can cancel out a sign as long as multiplication is what's between them. You can never cancel across an addition or subtraction symbol. Okay, you can only cancel across multiplication. Okay, like if you had something like this, let's say you had 2 plus 3 divided by 2, you can't just do that and say, oh, the answer's 3. The answer is really 2.5, 5 halves. Okay, so don't try to cancel across a plus sign, just across multiplication. All right, so now we have cosine over 1. And what's my other fraction?
Sine squared.
Sine squared over cosine. All right, so now we've done changing to sines and cosines. Okay, that trick's not going to do anything else. That already is sines and cosines. Okay, what trick could we use now?
Common denominator.
Yeah, let's find a common denominator. Okay. One way to find a common denominator is just to take the two that you have and multiply them together. So like if I asked you guys to take 3/4 plus 7.
Eighths.
Third.
Yeah, you could do 8. That wouldn't quite work for my trick, so I'm going to do 3.
You could easily get it.
4 times 3 is a denominator of 12. Okay, there's your common denominator. So what's my common denominator here? Cosine. Is there any fraction that already has that denominator and I can leave it?
Yes.
Yeah. The one on the right already has that denominator, so just leave that one alone. Okay. Now for the one on the left, what would you multiply top and bottom by?
Cosine.
Cosine over cosine. Now we have a common denominator of cosine. And what's cosine times cosine?
Cosine squared, dude.
Cosine squared. Why does this reduce to 1? That's a Pythagorean identity. Yep. On the paper, I think I wrote it as sine squared plus cosine squared.
Yep.
But cosine squared plus sine squared is the same thing. And now we get 1 over cosine, which is secant. Okay, so sometimes you end up with a very, very simple, very nice answer, even though you started out with something that was pretty complex. Okay? So all of that just reduces to secant. Okay, any questions on that? Okay, probably not the only way to do this problem, but I'm not sure that there's a faster way. Okay, with identities, there's multiple ways to get to the answer. Generally, we try to do it as efficient as we can. Okay, verify. Well, I would definitely start with the side that looks more complicated, which is which side?
Right.
The right. So somehow we'll just keep working with the right side using all the tricks we know so far. And eventually we should get sine as the answer. Okay, any thoughts here? Change what?
Changing the sines and cosines.
Okay, let's change everything to sines and cosines. So in the top, what do we get? 1 over cosine. And in the bottom?
Sine over cosine plus cosine over sine.
Sine over cosine plus cosine over sine. All right, so sometimes as we're simplifying it, it actually starts to look worse before it starts to cancel stuff out, like in this case. Right, well, in the top, there's not really much I can do. I'm not even sure that was a good idea to change it to 1 over cosine in the top. Maybe, we'll see. In the bottom, I think it was a good idea. Okay, what can I do in the bottom? Yeah, let's find a common denominator. 1 over cosine. What's the common denominator here?
Which of sine times that
Sine
sine.
times cosine. Or cosine times sine. Same thing. All right, so what do you have to multiply this fraction by to get a common denominator of cosine sine?
Sine.
All right, so we'll do sine, sine. And what do you have to multiply the other fraction by?
Cosine.
Cosine over cosine. Okay, any questions on that? So now, yes, we could do a couple things here. I'm going to do it step by step. So now we're going to get sine squared plus cosine squared. Okay, and now what does sine squared plus cosine squared become?
1.
Yes, all of this cancels and becomes 1. That's all done. Okay, now I have a fraction divided by a fraction. Okay, so how do I deal with that? Yeah?
Multiply the reciprocal.
Yeah, leave the one in the top the same. You know what? I think actually changing the top to 1 over cosine, now I'm seeing that was probably a good idea. Times, flip what's in the bottom. Cosine times sine over 1. Yep, and you can cancel that because that's not a plus sign. If it was, you couldn't do that. But it's multiplication, so we cancel. And what am I left with? Just sine. Okay, so you might be watching me do these and you're like, well, this doesn't seem that bad. I think when it gets tricky is when you do it on your own. Okay, you might not think to find a common denominator and then you're stuck. If you don't do that, I don't know how you would continue with the problem. Okay, so that's where you might get stuck on your own. But there's a very limited number of things to try. Change to sines and cosines, Common denominator. Okay, there's one more trick I haven't taught you, but those are pretty much, once I teach it to you, the only 3 tricks. All right, so the third trick is to use a conjugate. Okay, and not necessarily the conjugate of the bottom or the top. It could be either one. Okay, multiplying the top and the bottom by a conjugate. Okay, so just as a review, if I had sine of x plus 1, what's the conjugate of that?
What's the conjugate?
Well, think back to complex numbers. If you had 2 plus 3i, what's the conjugate of 2?
Minus 3.
2 minus 3i.
Okay.
So if I had sine of x,
Minus 1.
sine of x minus 1.
That was easier to do.
Yeah.
Okay, so conjugates are when you change the sign of the second term. All right, so this one wants us to show that cosine t divided by 1 minus sine t is the same as 1 plus sine t over cosine t. Okay, this is one where it really doesn't simplify. It's kind of like you're rewriting it, but I wouldn't argue that the left or the right is any simpler or more complex. All right, so which side do you want to start with? The left? The left? Okay. This one, it doesn't really matter. Okay, so we take the left. Changing to sines and cosines here. Is that going to work? We already have that. How about a common denominator? Yeah, 1 minus sine t is the common denominator. Okay, we don't have 2 separate fractions with a plus sign between them. We just have one big fraction, so we already have a common denominator. So the only other thing we can try is the conjugate. All right, so what's my conjugate here? 1 plus sine t. And it's a pretty good idea to multiply by that because look what's in the final answer. 1 plus sine t. So we're going to introduce the conjugate, which is part of the final answer. Okay, so probably on the right track. Right, now, in the top, you could distribute out the cosine. I'm not going to. Okay, I'm going to leave it factored. And the reason why, because it is in the final answer, so I'm hoping somehow this cosine just goes away, and I'm left with just the 1 plus sign. Okay, now let's FOIL out what's in the bottom. Okay, what's 1 times 1? 1. 1 times sine,
Sine.
and 1 times negative sine.
Negative sine.
Okay, so 1 times sine and 1 times negative sine, those cancel. And what about negative sine times positive sine? Negative sine squared. T. Okay, now at this point you have to recognize something up there that's special. Not exactly the way we wrote it, but very close.
Doesn't the 1 plus sine t factor out of the minus sine squared t?
Well, if we factor this back out, then it would just cancel and bring us right back to the original. So that does happen. Sometimes you do something and you're like, oh, wait a minute, I'm back where I started. Okay, so, but it is something with the bottom. Yeah?
Since sine squared t plus cosine squared t would equal 1 with 1 minus sine squared t equal sine squared t.
Yeah, it's this identity just rearranged. Okay, put that on the other side and look what you get. Cosine squared is 1 minus sine squared. Okay? So sometimes you can take a Pythagorean identity and just move something to the other side. It's the same identity, rearranged.
I was not
So,
noticing.
Keenan, what did you say 1 minus sine squared becomes?
1 minus sine squared t becomes cosine squared of t.
Okay, so the bottom becomes cosine squared. T. And now, what do the top and bottom have in common? Yeah, how many cosines in the top? In the bottom? 2. So you can cancel 1 from the top and 1 from the bottom, and look what you're left with. 1 plus sine over cosine, which is what they wanted. Now, had you started with the right-hand side, you would have multiplied top and bottom by 1 minus sine, and pretty much done the exact same thing. Okay, it would have been very similar. Okay, so that's a good one because I think it's the first time we've had to take a Pythagorean identity and rearrange it to recognize something. Okay, any questions on that one?
I'm confused on how you move the Pythagorean.
If you just subtract.
Do you see how this is an identity?
Yeah.
So all I did was subtract sine squared from each side, cancel that out, and I moved it to the other side. So it's cosine squared is 1 minus sine squared. Okay, we could also rearrange it. Let me show you another way. We could take this. Somebody tell me what else could I do with it?
Subtract cosine.
Yeah, I could subtract this. And here's another identity. Sine squared is 1 minus cosine squared.
When we have
Now,
1 minus sine squared.
This, you wouldn't see all of these written in a book. You're not going to see this one, sine squared equals 1 minus cosine squared, and sine squared plus cosine squared equals 1. That's the same thing rearranged 3 times. Okay, you'd probably just see the original, and you can rearrange it yourself. Okay? Any other questions on that? Everyone else is good? All right. Do you guys want to
No.
try this one on your own?
No, it's big.
All right. Well, we'll try one. I mean, I have a bunch. They're all. I just put up as many as we have time for. All right. We can try this one together, and then I'll have you guys try the next one on your own. Okay. Which side do you want to start with? You want to start with the left or the right?
Right.
The right?
Yeah, sure.
Okay, let's start with the right. Okay, so our goal here is to somehow get tangent squared minus 1 in the top, secant squared in the bottom. Okay, I want to go back to my original identities and just look and see if tangent squared minus 1 is anything special.
Yeah, it is.
Okay, so we have tangent squared plus 1, but not tangent squared minus 1. Okay, so that tangent squared minus 1 isn't quite a Pythagorean identity.
Yeah, if you use the conjugate.
Yeah, maybe a conjugate would come in somewhere. We'll see what happens. All right, so let's take the right-hand side, and what could we do first with it? Yeah.
Turn them into sines and cosines.
Yeah, I mean, that's really all we could try at this point. We'll change everything to sines and cosines. And hopefully after we do that, maybe denominators, something cancels.
It's supposed to be tangent squared x minus 1.
Oh, thank you. Yeah. All right, so we got sine over cosine minus, yeah, cosine over sine. And then, yeah, it's just reversed. Just trying to think if there's an easier way to do this problem. Okay, sometimes changing to sines and cosines, that is a good first step. Sometimes there's,
Can you do 1 over cotangent?
well, you could change tangent to 1 over tangent. And I'm just wondering if that,
If you just had all tangents.
because keep in mind, our final answer has a tangent in it. So by changing everything to sines and cosines, we're getting rid of something that we hopefully want in the final answer. Okay? Sines and cosines are not in the final answer. So for this one, you could try this approach, see where it takes you, but
There's a Pythagorean identity you use to convert to tangent.
let's try changing everything to tangents. Okay? Something we haven't tried before, but let's see, and if it looks like it's not going to work, we can always go back and do it this way. Okay, trig identities, especially when you're first learning them, it is a lot of trial and error. You try it. If you're going down a road and it seems like, you know what, this is getting worse, just stop and maybe go back to what we were going to try. So just right here, maybe try later if this doesn't work. Okay, so I've got tangent. I'm going to write 1 over tangent. And same thing, just with a plus sign. Okay. Tangent plus 1 over tangent. Okay, now what would be my common denominator in the top and the bottom?
And x.
Think of these as ones right now. Yeah,
Okay, tangent of x.
so we're going to do a common denominator of tangent x. Okay. What's the numerator going to turn into for this left-hand fraction?
Tangent of x.
Tangent x squared.
Tangent squared x.
Why is it squared?
Yeah, got the squared.
Why is it squared?
Because we're going to multiply top and bottom by tangent.
Okay.
So we're finding our common denominator. So we get tangent squared x. Anything else in the top?
Minus 1.
-1. Now I'm going to go back up. See, that's a good thing. So somehow I just got something that appears in the final answer. I think this is a better approach so far. I could change my mind at any point. So, what about in the bottom? Yep, multiply by tangent over tangent. Okay, and what do you get in the bottom?
Tangent x squared.
Tangent x squared plus 1 divided by tangent. This way was a lot better than what we were going to do. Now what happens there?
Tangents cancel.
Hey, you have the same denominator. You can cancel the tangents. And now we're left with,
Tangent x squared minus 1.
which is good, that's the numerator we want. Okay, so our top is right where we want it. The bottom is tangent.
Tangent squared x.
That becomes 1.
That's
That's a
the-
Pythagorean identity.
That's the identity that becomes secant.
Oh my gosh.
And that's it. Okay, had you done it with sines and cosines, I guarantee the number of steps would have been at least double what we just did. Okay, would have been a lot harder. In fact, I think I did it, an old way I did it with sines and cosines. But that way actually worked a lot better. That's the whole problem right there. So changing to tangents, common denominator, and then a trig identity. Okay. I bet this is one that if people probably would have tried sines and cosines, and you would have gotten stuck. Okay, you would have gotten to a point where it was getting really awful, and I would have said, you know what, try something else. Right, any questions on that one? So those rules that I'm giving you, they're guidelines, okay? Changing everything to sines and cosines, well, this time we didn't do that, okay? All right, this one is just basically something you would do before you do a proof. So let's say you had these two expressions, and you said, you know what, I don't want to waste time proving they're equal if they're not. Okay, well, what you could do, okay, is use your calculator, graph what's on the left, graph what's on the right. If they look the same, then chances are they are equal, and this problem is possible to do. If you graph what's on the left and what's on the right, and you get two totally different pictures, and you typed everything incorrectly, then you know they're totally different. Don't even bother trying to prove that they're true. Okay? So if you had a question that said prove if possible, that's where you want to take your calculator, graph each side, and see if they look the same before you start proving it. Okay. Any questions on how you type that in? Probably going to need all kinds of parentheses here just to make sure we type it in correctly. But everyone feels like they could type that in? No concerns about that? All right. And you don't have to prove it. It just says use a graphing calculator basically to state whether or not you think it's true, but you don't actually have to prove it. Okay? So this is not a proof, just a calculator one. All right, so we have two left. This one and this one. Okay, why don't you guys try that one a little bit? Okay, so just see if you can figure it out. Okay, somehow you're going to get a very nice answer. Okay, just negative cosecant. Okay, but try some different things and see if you can get it. All right, so the first thing I did is I started with the left side, definitely more complex than the right, and I found a common denominator. Okay, so what's my common denominator here?
Tangent x cosine x minus.
It's the product of the two that I have. Now for the fraction on the left, what is this denominator missing to be the common denominator?
Cosine x minus 1.
So you got to multiply the top by cosine x minus 1. And when you do that,
Cosine x minus 1.
yeah, it's a distributive, but it's just times 1. So it's just cosine x minus 1. What's the denominator missing on the right?
Tangent x.
Tangent. So I got to multiply top and bottom by tangent. Okay, so that was first step. Okay, next step, I tried changing to sines and cosines. And then there is something that cancels out, but not as much as you would hope. So keep the first part. And now, in this part,
Sine x over
I'm
cosine.
just going to change it right here. What do you get when you multiply sine over cosine times sine?
Sine squared x over cosine x.
So sine squared over cosine. You got that?
No, I got it about that far.
About that far.
That's where I got stuck.
Now, in the bottom, we do get something that cancels. This becomes sine over cosine. And when you multiply sine over cosine times cosine, what happens?
Cosine's cancel.
Cosines cancel, which is nice. But then when I multiply this times negative 1, nothing cancels. Okay, it's just minus sine over cosine. All right. Okay, now, what I really don't like here is having this denominator and this denominator. If I could just have a fraction, that would be easier than having a fraction, and then within that fraction, another fraction and another fraction. So what I want to do is get rid of this denominator. what could I multiply the top by so that if I distribute it out, this denominator would cancel? And how about in the bottom? Okay. My only reason for doing that is I don't know where this is going to lead me, but I really don't like this, and I don't like that. So maybe if I get rid of it, I'll end up with something that I can work with. Okay. So we need to do that. What's cosine times cosine? Cosine squared. What's cosine times negative 1?
Negative cosine.
And what happens in the last part?
Cosines cancel.
The cosines cancel. So I just have a sine squared. And now I'm seeing a sine squared plus a cosine squared in the top. Okay, that's a good thing. We can look at that in a second. And now in the bottom, what do we get? Sine times cosine. How do we write that?
Sin x, cosine x.
Just sine x cosine x. And what about the second part?
Cosines cancel.
Cosines cancel. Okay. Questions on what I just did there? I just multiplied that out. Okay. Now, what happens in the top here? We have a sine squared plus a cosine squared.
Equals 1.
Yeah, we can cancel this out. And that all becomes a 1. Whether you put 1 minus this or this plus 1, it's the same thing. Cosine squared and sine squared becomes a plus 1. And now, what do you have in the bottom that's common to both? Sine x. Okay? So watch what's going to happen here. 1 minus cosine x divided by. What if you factor sine out from the first part? You get cosine x minus 1. Now, these two things almost cancel each other. 1 minus cosine, cosine minus 1, except they're
Negative.
opposites.
Also, you get negative 1 over sin x, which is negative secant.
Right.
Secant.
So you can cancel them.
Hey, we're done.
Okay? It's okay to cancel them, but just make sure you leave a negative in there. Okay? They cancel except they're opposites. And now, what do you get if you flip sine? Cosecant?
And you're negative.
But it's a negative cosecant. Okay, so that way worked. Okay, I'm definitely not saying that's the best way to do it. There might be a much, much better way, much shorter. But that's how I thought about doing it. Yeah.
How did you, do the second last step?
This step?
Yeah.
So this is kind of going back to algebra. If you have something like this, it's always equal to negative 1. Two things that almost cancel, except the order is switched. When you divide them, it's negative 1. You could try it with numbers. Like, let's try like 5 and 2, and 2 and 5. What's 5 minus 2? 3. What's 2 minus 5? And when you divide 3 by negative 3? Negative 1. So anytime you have two things that are just switched, they cancel and become negative 1. So that's why this became negative 1. Okay? And the sign stays right where it is. That wasn't affected.
Oh, no, how did you get to that step?
Oh, this step?
Yeah.
So since sine is common here and here, I factored sine out from the first part, and that leaves me with cosine. And when you factor sine out from the second part, you're just left with 1. So that bottom I factored, and the top, this was a Pythagorean identity. I didn't rewrite it. I could have done this. Sine squared plus cosine squared minus cosine. Okay. If I wanted, I could have done this. And then that becomes 1 minus cosine x.
What's the homework?
No homework.
This one.
Yeah.
Okay, so this is an identity that's definitely seems pretty hard. Maybe there's a better way, I'm not sure. Okay, so tonight's homework, not that many problems, just page 407, 4 to 8, 11 and 12, 21, 22, and 25 to 27. Okay, a few of them are just graphing on the calculator. You do not have to prove. Okay, and make sure you check for the review video tonight.